A conscious moment is created by quantum processes, and it has to do with experiencing a single classical reality, even though quantum mechanics tells us there's this multitude, that you also get at the moment of creation of a superposition. So it's important. The key lesson here is that quantum physics tells us that every object exists as a multi-object, and we have to keep track of all these possible configurations simultaneously.
Hartmut Neven is the Vice President of Engineering at Google, and he's the founder and manager of the Quantum Artificial Intelligence Lab at Google. Today, Hartmut proposes something I find fascinating, which is, look, Penrose thinks that when you have a quantum superposition and you collapse, you produce a conscious event. Hartmut believes the opposite. Perhaps when you have a superposition created, that is what produces consciousness. This talk was given at MindFest, put on by the Center for the Future Mind, which is spearheaded by Professor of Philosophy Susan Schneider. It's a conference that's annually held where they merge artificial intelligence and consciousness studies, and held at Florida Atlantic University. The links to all of these will be in the description. There's also a playlist here for MindFest. Again, that's that conference, merging AI and consciousness. There are previous talks from people like Scott Aronson, David Chalmers, Stuart Hameroff, Sarah Walker, Stephen Wolfram, and Ben Gortzel. My name's Kurt J. Mungle, and today we have a special treat because usually Theories of Everything is a podcast. What's ordinarily done on this channel is I use my background in mathematical physics and I analyze various theories of everything from that perspective, an analytical one, but as well as a philosophical one, discerning, well, what's consciousness's relationship to fundamental reality? What is reality? Are the laws as they exist even the laws, and should they be mathematical? But instead, I was invited down to film these talks and bring them to you, courtesy of the Center for the Future Mind. Enjoy this talk from MindFest.
I'm very delighted to introduce Hartmut Neven, who's the Vice President of Engineering at Google and the founder and head of Google's Quantum Intelligence Lab. And, we were just chatting about consciousness the other day, and I said, hey, why don't you come down and join MindFest? And he said, why not? So here he is. Very happy to have you.
Yes, thank you very much, Susan, for inviting me, and it has been a very fun day so far. So I want to conclude the day with telling you about work that pertains to testing the conjecture that quantum processes create conscious experience. And this is work together with Professors Kosick and Baumeister at UC Santa Barbara, who run a brain organoid lab, also with my friend Christoph Koch, and quite a number of students are involved in this work as well. So the talk will go as follows. I first want to state as definite as I can a conjecture as to what constitutes a physical correlate of consciousness. And then next, I want to go through a sequence of quantum biology experiments that will be able or should be able to test this conjecture. And then we can look a little bit, in case these ideas are correct, then we can build interesting brain quantum computer interfaces and think what they would do for us. And then a little bit as an addendum, but it's an idea that nicely runs with it. We had this already earlier today. Does agency, free will exist? I think there is, out of these ideas comes also naturally a nice suggestion where moments of agency may reside. And that's the final piece I want to talk about. So let's start first with stating the conjecture. So I'm strongly influenced here by Roger Penrose and the work of Stuart Hameroff. And I think most in this room will know Roger's seminal book, The Emperor's New Mind, was published in 1989. And it had the idea that a conscious moment occurs when the quantum mechanical wave function of a system collapses via a process Roger calls objective reduction. And down there, I think I have a little marker. That's the formula that shows how a superposition state collapses. Now, earlier, Sarah asked how many physicists are in the room, and I think there were less than a handful who raised their hand. So if you allow, I will just explain what a superposition is one more time, because if you don't understand this object, you will not get much out of this talk. So in a, let's say, popular science talk, there are different ways how you can do it, but one way how I like to explain superposition is as follows. Let's set up a system. Typically, I nestle them and find a few coins. Let's say I find 3 coins and I throw them on the table. And just imagine I did this right now. So there's 3 coins on the table. So a modern physicist, the numerical physicist, would say, oh, there's a 3-bit system. Now it's 3 times heads and tails, or zeros and ones. So there's 3 bits, a 3-bit system here on the table. And let's assume, for simplicity, they're all head. So what we do in everyday reasoning and what classical physics does, we make predictions. And to make a proper prediction how the system will look like in a minute from now or 10 minutes from now, we need to know which forces act on the system. Yeah, so I need to know, for example, that George was going to come by and going to flip around one of those coins. And maybe I know other people doing this as well. So let's assume I know all the forces that are going to act on the system. Then what I can do is, at a start time, system is in heads. Now, knowing all the forces, I can predict how the system is going to evolve and look in a minute from now, and then maybe it turns into tails. Yeah, this is how classical physics works. It's also how everyday reasoning works. So now a quantum physicist would come in and say, yeah, pretty good. This type of explanation works most of the time. But actually, it's not quite precise enough. If you want to make a really very exact prediction of the future, you have to not only consider the configuration you see here right now, the heads, but there can be 8 configurations overall. No, because we have 3 coins. Each coin can be in 2 positions. So if you think about it, you can make 8 configurations. And quantum mechanics tells us that we need to consider all these configurations. Even though they're imperceptible to us right now, there's somewhere nature holds all these configurations, and we have to calculate how each configuration is developing over time under the same prevailing forces. And then we need to add up all the outcomes after a minute, if I'm interested to predict in a minute, add them up in a smart way, and that gives us then probabilities what configurations we're going to see after some point in time. So it's important. The key lesson here is that quantum physics tells us that every object exists as a multi-object, and we have to keep track of all these possible configurations simultaneously. Yeah. And then it's important to appreciate the fact that we told the story about the 3 coins, and often quantum mechanics sort of is thought of as the physics of the microscopic, but that's actually not correct. As far as we know, the laws of quantum physics are correct on all, or apply to all scales. So it, for example, applies to our scale here as well. And we are sitting here in one configuration right now, but the most literal interpretation of the equations of quantum mechanics would say the other configurations exist also. So you, let's say, swapping seats, or you swapping seats. So this gives us an opportunity to place a moment of consciousness in an interesting way. There is the world of the many configurations, the world of superpositions. Earlier today, people used these terms already, the multiverse, parallel worlds, that's associated with it. Now, every set of coin essentially lives in its own parallel classical world. Yet us, we only at every moment in time only perceive a classical single configuration, never multiple configurations at the same time. So going back to Roger's original idea, so this object that you see here, the superposition state, for the case of the coin, would just be adding up. So it would be a sum over 8 terms, and the configurations of the coins would appear here. And then if you measure it, at the end, you would see one of the 8 possible configurations. And Roger's suggestion was very definite. He said a conscious moment occurs when such a superposition state, holding multiple configuration, collapses into a single classical configuration. So it's this nice idea of sort of consciousness acting as a reducing valve, bringing a richer reality down to the concrete one we experience. And moreover, he suggests that this reduction happens through gravitational influences. But even though my work is very much inspired by this, there is, as George Musser nicely observed, is a whole package of ideas bundled together, and you can actually tease those apart. So first of all, the gravitational influence I don't like very much, simply because so far, even though it's testable, to Roger's credit, it's testable, so far experiments have come up short finding it in the lab. So I would rather go with traditional collapse theories as we use it every day, say quantum physics or quantum computing. Actually, one day I recall Roger and Stuart, they came, visited the Quantum AI lab, and they asked, hey, Hartmut, wouldn't gravity-induced collapse not limit how big of a quantum computer you can ever build? And then one of our team members, Kostya Kececi, he actually computed it. And it turned out if gravitation would be the only decohering process, then our qubits should lose their superposition property after some time. But this time would be 10 to the 6, 1 million years. However, in practice, our qubits decohere after 10 to the minus 6 seconds, so way quicker. So I told Roger, before gravity gets out of bed, our qubits are already decohered. Now, of course, this isn't per se like falsifying Roger's idea, because when we measure a qubit, then macroscopic amount of degrees of freedom get involved, and then atoms get displaced, and we may reach Roger's threshold. But so first thing I would like to do is leave out gravity. But the second idea, and I will get to this in a second, is I would like to generalize Roger's idea, and I call this a generalized Penrose-Hameroff conjecture, and just say consciousness is how a system experiences the emergence of a unique classical reality out of the multi-classical realities that the equations of quantum mechanics tell us are there. But it doesn't necessarily have to be located at the moment of measurement. And let's look into this a little bit more carefully. So here I wrote down a very an arbitrary little example for a quantum circuit. Quantum circuits are typically visualized. We call it often quantum sheet music. This would be sheet music for 3 qubits. The lines is essentially in this direction of time. And then these little boxes are operations you do on your qubits. Like you have 1 qubit operations, you have 2 qubit operations. So, for example, we start out by creating a superposition. So we put the first qubit in the superposition. Then here in this step, we entangle the first qubit with the second, and the second with the third. And then you get to a state here, 0, 0, 0 plus 1, 1, 1. And then at the end, we measure it and we collapse the superposition. It's a very plain vanilla, simple quantum algorithm. Things like we can run on our computers any day, and actually way more complex ones. So looking at Roger's original suggestion, the moment of consciousness occurs when the superposition collapses via a measurement. And let's not get into the fight right now whether gravity was involved or not. for what I'm going to say next, it doesn't matter. Just a qubit gets measured. And I want to be specific. Let's assume we measure the first qubit. So now I can ask the question, okay, Roger, we have 3 qubits here. Which of the qubits has a conscious moment, or a Bing moment, as Stewart likes to call it? Yeah, and one thing I noticed in Roger's papers, OR is typically always discussed just with a single qubit. It's typically a picture where you have a single electron goes into superposition and then splits space-time and it snaps into one. But of course, it's completely legitimate to ask, hey, how does objective reduction work in the context of multiple entangled qubits? In my little example here, how does it look for 3 entangled qubits? And then again, I can ask, I measure the first one. In this case here, in standard quantum computing lingo, we would say, okay, I measure a 1. So I immediately know this state here is collapsed, and it must be the state 1, 1, 1. So do all 3 qubits feel something, or only the first one? I think both answers are distasteful. Why? If all 3 of them would feel something, you open the door to faster than light communication. Because normally we know the beginner mistakes that often happens when we discuss Bell pairs or entangled states. Then when people get freshly into quantum physics, they think this is a mechanism to transmit information faster than light. But that's actually not the case. You should think of entanglement as a form of correlation. So the measurements are correlated, but a measurement on one part of the circuit doesn't cause something to happen on the other side. Actually, you can prove, it's standard knowledge in quantum computation, that if you split these circuits, then I can do an operation on one half, then there is no local observable I can do on the other half that would tell me that the measurement has occurred. So there, no faster than light communication is possible. But Roger's suggestion or proposal actually opens this back up. If all 3 qubits would experience something, then you could build a Morse code out of this. So I think that can't be the answer. But that's sad because, in a way, entanglement is a nice binding agent. It would put these 3 bits together to a unitary experience. But this, unfortunately, is out of the window if we don't want to risk faster than light communication being possible. The second answer is also distasteful. You say, oh, no, it's only the first qubit that has an experience. Then I would say, okay, then the entanglement doesn't really matter. It's essentially a qubit encountering a measurement device that I can do classically too. It's essentially a system interacting with another one, creating a conscious moment. So I think both answers are not exactly great. That's why I think we should maybe get away from locating a moment of conscious experience at the moment of collapse of the superposition. And actually what I'm going to convince you of, that it's much nicer to go to the moment where superposition is created. I will skip maybe about why don't I put it there in entanglement piece. We can maybe leave this for discussion. But I think you get the basic idea that a conscious moment is created by quantum processes, and it has to do with experiencing a single classical reality, even though quantum mechanics tells us there's this multitude, that you also get at the moment of creation of a superposition. But there, you don't run into danger to violate special relativity. So, what I would like to propose, therefore, as a conjecture, is a conscious moment occurs whenever a superposition forms, not, as Roger and Stewart suggest, when it collapses. So I would still lay all credit to this general thinking. at their feet, but it's, I think, an important modification of the original idea. And now to be super definite and lean out of the window so that you can later sort of have an easier time falsifying the ideas suggested here, let's look at different state transitions. Yeah, for example, Christoph Koch, he asked me, hey, if a state is just sitting there, is it conscious? I would say no, because no superposition forms, so according to this hypothesis, no associated experience. Or you just rotate your qubits to a new classical state, no superposition forms, no experience results. Yeah. You could also consider a transition like this, where we go from a 0-0 state into a superposition of 3 states here: 1-0-0, 0-1-0, and 0-1-1. 0-0-1. So in this case, a superposition does form, and here the associated experience, I would say, is either one of those. So the system will, for example, experience something like described by the bits 1-0-0. Yeah. So, and you can go through other cases, but essentially, for those of you, probably most of you are not, there's a notion of a Feynman path. A Feynman path essentially connects a classical configuration with another classical configuration with another classical configuration. And you can essentially integrate the Schrödinger equation, which is the evolution equation for quantum mechanics, by considering all possible Feynman paths. Actually, what I explained to you earlier with the coins is sort of this business. You have to look at all the different Feynman paths. But in the multiverse interpretation of quantum mechanics, each path, each history, each trajectory happens in its own universe. But essentially, a human, you should think of yourself as you follow one Feynman path of the many, many Feynman paths that are possible. Yeah. That is, and whenever you come to a fork, at that moment you experience one or the other or yet others. That's the proposal. So, okay, so at least a concrete suggestion. The physical correlate of consciousness is here. So now let's think, can we test this, or are we still in the realm of metaphysics? I hope something I can deliver here to you is that we take a question that typically resides, or until very recently resided in the field of metaphysics, take it to physics, quantum physics, or rather quantum biology. So how can we test it? And here's a suggestion. So typically, or often, the field of, when you talk about the question of what constitutes consciousness, that's often met with suspicion or with skepticism by colleagues, because they feel this is not really a question rooted in the realm of experimental science. And the reason is there is not a clearly associated measurement protocol. My example is, always take an airplane. Let's say an airplane, the engineers build a new jet engine, and they predict this jet engine is going to propel the airplane to 1,000 kilometers per hour. Then any engineer knows what to do. They whip out a stopwatch, they whip out a measured stick, and they can see, yes, it's going to go 1,000 kilometers per hour. But now we ask the question, the autopilot. Look, it has a lot of sensors, it has memory, it has computational capabilities, it has actuators. So autopilot, when it's controlling the airplane, is it conscious? We can ask that question. And then we go to our colleagues like Christoph Koch or Giulio Tononi, and we ask them, calculate the phi value for the autopilot. You can do that. It's a bit difficult, as you can read on Scott's blog, but in principle, you could do it. So let's say they come up with a phi value of 1,000 for the autopilot. But then what is next? Yeah, how do you measure it? There's no associated measurement protocol, and therefore it's vacuous. And therefore, in the same way, I feel the discussion of whether LLMs have become conscious or not is a bit vacuous in the absence of a clear measurement protocol. And to make matters worse, philosophers, there's the philosophical school of solipsism, which states, maybe I'm the only thing that is conscious in this world. And philosophers have worked out that the position of solipsism is logically closed. So strictly speaking, I cannot convince you that I'm conscious. You only know it for yourself. So in this situation, how can we ever bring it to experimental science? But I think there's a method or there's a loophole to this. And the loophole is what I would like to call the expansion protocol. Yeah, so this is a way how we are going to test it. And the experimentum crucis, Luca Turin likes to use this word, so experimentum crucis sounds cool. So the crucial experiment, how we are ultimately going to test this idea is as follows. We have a human brain, and inside there, I think no biophysicist would vehemently object, inside my cells, somewhere inside my proteins, superposition, quantum mechanical superposition states form. I think there's no big debate about this. Then in our lab, we make quantum chips every day. We make superposition states there. So it's also everyday business. So we have a Psi chip there. But initially they're not coupled. So they live in quantum compute jargon in a tensor space. So we have Psi-me tensored with Psi chip. But now we are going further. We are going to make a coherent coupling. And coherent coupling in this sense means that a superposition can be created between both parts. So we will later do it more elegantly, but for now, just think we stick a nanowire into the brain, sort of measuring suitable degrees of freedom. So to make Stuart happy, we stick the nanowire into a microtubule or take it close to a microtubule, because there are many other systems we can think within the nervous system where we might go. But we now couple degrees of freedom in the brain with degrees of freedom on the quantum chip. And now, if this is a coherent connection, a wave function, a superposition state should form that I would like to call Psi-cyborg, because now it contains both parts. And now I can use this to test. For example, you come into our lab, we hook you up, then George, let's say you are a test user, then we could sit there, and initially we don't activate the coherent connection. But at some say, hey, George, how are you doing? How do you feel? Well, like I'm always feeling, or like, yeah, great visiting. And how about now? Oh, still the same. And then I press a button under the table, and then what should happen is, or should be able of providing you a richer experience. Richer because Psi-me is typically spanned over n qubits, and Psi chip is spanned over m qubits, and now this is spanned over n plus m qubits. So I should be able to create a richer experience. And moreover, by suitable post-selection, or we can talk about the method, I can ask you, how did you feel? Like, did this make you sad? Did you just feel good about this? We could look into what state do we see the qubits in, and then we get maybe an idea how qualia are implemented. So we should be able to A, make richer experiences, and B, dial in qualia. So at least on the face of it, this should work. But now you become, whoa, Hartmut, how are you going to do a coherent connection? You cannot even do this well with two quantum chips. Like, Jesus, this is very complicated. And you would be right. So this experiment is technically very challenging. So at this point, it's a conceptual suggestion, but I feel a clean conceptual suggestion. But now let's go to a program. How do we get there? So let's assume we want to do this in 10 years. So let's work our way backwards from the experimentum crucis to stuff we can do today to learn how to create such a coherent coupling. Yeah, so now let's go one step down. And this is where I met my newfound collaborators at UCSB, and Dirk Baumeister, who actually happens to be a four-year postdoc of Roger Penrose, so he loves Roger's ideas, and Kenneth Kozik is a known neuroscientist. They run a brain organoid lab at UCSB. So you could go there, scratch a few skin cells from under your arm, then they will take those skin cells and turn them into what's known as an induced pluripotent stem cell. And out of the stem cell, you can grow like little lentil-sized organoids that will be essentially generic brain tissue made from your DNA. And these brain organoids are exquisitely instrumented. This is where Dirk Baumeister comes in. So they sit on 20,000 electrodes, so a very high density electrode array. And more magical, the electrode array is transparent. So you can simultaneously also do optical recordings. So we can really look at these organoids in many, many ways. You can even throw them into an NMR machine later on if you would like to. So these are highly instrumented, generic, is typically from human cortex. So there's a little bundle of pyramidal cells, but also the typical cell mix that you would find in the cortex, creating generic cortical activity. So here we could use this. My idea before I met them was, hey, why don't we do the following? Actually, the constructor theory people, I got these ideas from Chiara Maletto and David Deutsch. They suggest, and they have used it for other systems, but they suggested the following tripartite experiment. You take two qubits, and you take a first qubit. Of course, we want to take room temperature qubits, so let's say nitrogen vacancy qubit, and we generate a coherent connection to the brain organoid. And then the brain organoid gets, or you can put a B here. This can be anything, any B for biological system you would like to study. In our case, I would like to use brain organoids. And then you connect this to a second qubit. And now, this is just math. If we could use the biological matter, the brain organoid, as a quantum channel that mediates entanglement between Q1 and Q2, and how to measure entanglement between two qubits. This is just first semester quantum computing. Every student would know how to do this. So we could see, in principle, can I generate entanglement between Q1 and qubit 2 via B as a channel? And if I can, then I know that B deserves, at least in part, a quantum mechanical description. So this is a nice training ground to learn how to connect qubits to biological tissue or to nervous tissue. So this was before I met Ken and Dirk, and then Dirk Baumeister, very down-to-earth experimental physicist. And Hartmut, come on, how do you exactly want to couple to magnetic degrees of freedom? Do you want to use photons? How do we do this exactly? And then we discussed this for a while, and then I keep talking to my friend Stuart, who told me about an exciting experiment, which before I get to that experiment, let me show you a few more pictures. So these are actually the organoids. So this is like a little glass. Again, these are lentil-sized. And then here you see various staining techniques. They have done many experiments with them already that are quite relevant to what I'm going to show you next. And you can measure spikes in the organoids. You can look at local field potentials. You can look at synchronized spikes called bursts in neurobiology language. So again, highly instrumented systems to study nervous activity. And coming back to the idea that Stuart suggested, he pointed me to a paper a few years ago, 2018, by a Chinese group that looked at the following. They used xenon, and I didn't know this. Xenon is an anesthetic. So if you inhale xenon, if you will go out. And interestingly, this is a little bit miraculous already. Now it's an inert gas. It's a noble gas. What does it do in a body to knock out consciousness? This is a bit peculiar. But even more intriguing is that if you take different isotopes of xenon, they seem to have different anesthetic potency. So what the Chinese group, Li and al. Did, they used 80 mice, split them into 4 groups of 20, and then exposed them to xenon and looked what the partial pressure has to be in order for half of the mice to plop over and essentially lose their writing reflex. So what we want to do is we want to repeat this experiment, but statistically much more solid. So at UCSB, we hope to use about 1,000 organoids. And we just bought 5 different isotopes of xenon, heavier and lighter ones, and some with spin 1/2, others with spin 0. An isotope, I think all of you know, but they're essentially distinguished by different numbers of neutrons. And so there's a small mass difference, but xenon is already pretty heavy. So it's unlikely that the mass effect would have anything to do with it. Moreover, since we have lighter and heavier ones, we should be able to exclude this effect. So our hypothesis is it has to do with the nuclear spin. If it's a half integer spin, they found the anesthetic effect is reduced. And if it is 0 spin, then the anesthetic potency is higher, which actually fits very nicely with what Stuart told us this morning. If you think of these spins as little extra qubits, we can easier make bigger superposition states. So this sort of rings true. So we are going to do this experiment. Different isotopes will be used to expose the organoids, and then we want to see, do we see differential signals from the electrode or optical rays? And then Christoph insisted, hey, we need behavioral data too. So we called our friend and colleague Luca Turin in the UK, who actually works with Drosophila, and they live in an electron spin spectroscopy device, so he can measure electronic spin signals from within fly brains. And then we will do the same thing. We will expose them to different isotopes and see whether there is a difference. Let's say, when do half of the flies fall to the ground? Are there different partial pressures for xenon? So there is a chance this experiment will just not work, and we can't confirm Li et al. Experiment. But if we were to confirm it, that would be super interesting. Then it's really, I think, sort of a smoking gun experiment, like that quantum effects do matter, and matter here in conjunction with consciousns. So these xenon experiments, also I should say here, we are grateful to the Tiny Blue Dot Foundation of Elizabeth Koch. She has funded all the academic collaborators in this work. So, moreover, if we see a xenon isotope effect, then we can, I like to think of it, crawl after the xenon and say, where are you going? What exactly are you doing? And with the highly instrumented brain organoids, I hope we get an idea where they go, and then we can hopefully answer Dirk Baumester's question, to which degrees of freedom do we want to couple our qubits to make a coherent connection. So this is our entry door experiment. And earlier I said, in principle, we should be able to make David Chalmers happy and say, okay, let's dial in qualia on demand, because in principle that should be possible. And of course, we don't want to do it Neuralink style with an actual invasive surgery. Who wants to do that for their brain? If you're healthy, it's probably not good proposition, but we wouldn't necessarily have to do this. I mean, the whole idea, if spins really matter in biology, then you have a whole new way of controlling biological matter in real time, because you can flip those spins around and use them as control and readout. So medical spintronics or biological spintronics might be a field of the future where you can control nervous or biological substrate in real time at a very fine level, at a quantum level. And assuming we could do this, then we could think of devices that expand human consciousness in the sense that we can expand it in space, time, and also complexity. Because right now we are all limited. The number of bits needed to describe conscious experience is probably not all that much. It's more like sort of the executive summary of what's going on, and literature sort of is not quite agreeing, but it's between 100 to 100,000 bits per second, which is not all that much. So we could essentially break out of this and expand our propensity for conscious experience. And the last thing, since I'm out of time, earlier there was a discussion on whether agency exists or not. And I was sort of eager to, let me help you out. I think I thought about this and I have a suggestion. And what I want to, of course, I'm looking, is there sort of something that today's large language models do not have that is sort of a telltale sign that the current computational substrate we use, which is probabilistic Turing machines, is not sufficient to bring about conscious experience. So I would argue Turing machines have become intelligent for all practical purposes. They pass the Turing test. Or imagine we hook an LLM into a telephone and go back in time and have Alan Turing talk to ChatGPT-4 or to Gemini. He would probably be convinced, of course, there's a human on the other side. So in that sense, I would think they have passed the Turing test. But I would argue, if these ideas are correct, of course, they can never become conscious. And to make this a little bit more specific, I would say the following. See, in any scientific attempt to explain consciousness, you're tasked with reconciling two perspectives. You have to reconcile the third-person perspective of a scientist looking at you with the first-person direct experience of the world. And here I would suggest a good point of departure is to consider situations where these two perspectives are correlated. And here I would suggest the following. Look, there seems to be a clear or strong correlation between behaviors that are conducive to my well-being, conducive to my homeostasis, and pleasant versus unpleasant feelings. So if I eat nutritious food, or I am taking a warm shower, or a nap in cuddly blanket, the third-person scientist, my doctor, would say, oh yeah, Hartmut, keep doing this. This is good for your health. And I would say, oh, that feels agreeable. And if I go close to fire, the third-person doctor would say, don't do this, and it hurts. So how can we explain this correlation? And here I would say the answer is probably agency. Because in a world which is purely deterministic, see, evolution is like an anonymous engineer. It's the same way I cannot tell your feelings from the outside, so can't evolution. So if we are dealing with agents who are purely deterministic, this correlation you will have a hard time explaining how so homeostatic correlation could come about. And in what we call a probabilistic Turing machine, where you also have access to a source of randomness, where essentially a roll of a die decides what you're going to do. In this case, also, it really doesn't matter how you feel. The same thing would result. So I think the solution is, if an organism possesses agency to choose a state, then presumably it would choose this to pick emotionally rewarding over unrewarding ones. And maybe here, this is the last idea. See, I earlier tried to convince you that when a superposition state forms, this is where the physical correlate of consciousness resides. And it goes beautifully hand in hand with, does a system really have in an individual run, no choice in which path to go? we look only at it on an ensemble level, but never for a system by system trajectory. So I think a conscious moment could perfectly go hand in hand with a moment of agency, and that's how these things would hang together. Okay, I skipped the rest. Thank you for your... too many. So this is the last slide I want
to... Okay. So now we're ready to have some questions. So let me just... Oh, Misha, since you've been volunteering.
Sorry. My question is with your idea that it's superposition that is related to consciousness and also agency, which you keep connecting it to, isn't whether a state is, and I might be understanding this wrong, whether a state is in superposition or not depends on the basis of states in which you measure.
Yeah, that's it's a very good question, actually.
And isn't that distinctly external, if that is correct?
No, you're right. Actually, I had it in the cons. I didn't read this off in the table where it says the pluses and minuses of each suggestion. Actually, the minus is you're putting on it. Indeed, what is a superposition state is a basis-dependent notion. But it doesn't concern me too much because it has been worked out that in practice, often preferred bases that naturally emerge in a system, so as pointer bases. And I just assume that there is a naturally selected preferred basis. But that is a minus of this suggestion.
All right, I get to... Oh, Scott, go ahead. And then I have a question too.
Hartmut, suppose hypothetically that someone believed that like quantum mechanics is universally valid, but consciousness is some, higher level, emergent neuronal thing. And so, all of these experiments, what they're going to do is reconfirm quantum mechanics over and over, but at no point will any consciousness ever be implicated in it. Like, would you have an argument that that person is wrong?
Again, I'm sorry, I don't want to dial back too much, but I just want to maybe put it up so we can all stare at it. In this, so first of all, like Stewart's or the original Penrose Hameroff ideas, it leads to a panpsychist view. Like superposition states form all over the place all the time, and I would say little Bing moments, little conscious moments are associated with this. So maybe they are useful superposition states, and therefore evolution, our brain has sort of harvested to make it more orchestrated and bring more bits into superposition. And whether that's true or not, we could test in this setup.
No, I just wanted to mark that like the panpsychism seems presupposed here. Like it's not like we're finding out about it by doing the experiment.
The conjecture, it directly follows from the conjecture. Yes, that is correct.
Yeah, that was exactly my concern. I mean, it seemed to me if you can mediate entanglement with the organoid, yes, it deserves a quantum mechanical description, but what further step gets you to the point that, which is what I think we need, that the mediating properties are actually relevant to the production of consciousness, or, I mean, if you're looking at it in terms of cognition, which is also interesting, cognition. So how do you get from just because something serves as a mediator to the further point that it's part of the neural basis of consciousness or cognition?
Yeah, so the organoid experiment is really only a training ground to learn how to make a coherent connection. Because I said, the ultimate experiment, the only way how I can convince you or Scott that I'm right is hook you up to a quantum processor, make a large superposition there, make you participate in the superposition, and then we see how it goes. If then you report back, oh my God, then maybe you start to think, oh, maybe these conjectures are correct. Because the timing of when this richer experience should happen, we have under our control. Possibly we could dial in qualia. The organoid experiment doesn't tell this to us. We only have third-person view on this. But the organoid experiments would teach us what to use. Shall I couple to spins, let's say in the centrioles, that could be a good pick, or there have been other suggestions. Matthew Fisher is talking about phosphorus spins as possibly implicated in entangled states in the brain, and many suggestions have been made over the years. So we want to use the xenon experiments to find out where are promising degrees of freedom. Then we want to coherently couple via these degrees of freedom. And once this is all set up, then eventually comes the human experiment.
It could be safer than doing acid. David.
Yeah, just on your idea that consciousness goes along with the moment of superposition. I mean, one strong motivation for the idea that it goes along with collapse is that in typical perception, we experience things being, in one location and not two. We experience, hot or cold, but not both, and so on. So I'm wondering whether your view would tend to predict the opposite. If consciousness goes along with superposition, then we'd expect it to go along with. You'd either expect it to go along with superposed states of consciousness, or you'd have a selection of one of the two. Neither of them seems terribly plausible. So I'm just trying to see how that goes on your picture.
No. In this picture as well, it's when the superposition forms.
Yeah.
And the assumption is that we all only ever experience classical definite states. Yeah. But sometimes, let's say you come into our lab, and observe one of our qubits, and you see, it's in the zero state. There would be another David now in a parallel universe that I've seen the one.
Okay.
You only follow one path. That's why I earlier used the word Feynman path. So you should think of yourself as an electron following a Feynman path, and it only goes from classical configuration to classical configuration.
So it's going to be effective. So it's going to be effective collapse for the perceiver. Yeah, like the wave function goes into a superposition of hot and cold, and there'll be one perceiver who experiences hot, and another separate perceiver who experiences cold, and for both of them, they'll be like different Everett branches, and it'll be for them as if
absolutely
their wave function has collapsed.
This idea, I didn't explicitly say it, but this idea is firmly rooted in the multiverse view of quantum mechanics. And Everett in a thesis 1957 was the first one to point out that quantum mechanics really describes a multiverse, and that the measurement event we can really dispense off. We don't need it. Okay.
Thank you, Hartmut. So when the superposition occurs, the one Hartmut goes to one universe, or one Dave goes to one, and the other one, is that random?
I would say no. That goes where agency is. Maybe I have a choice in this. Now, that's a beautiful place to locate a moment of agency.
Well, how does that happen? Consciousness is going to choose that I'm going to go to this branch or that branch?
Yeah, it could be I'm in state X right now, or a system is in state X. And if there are at least two other classical configurations it could go into, maybe because you apply a Hadamard gate to one of its qubits, then it can go to states Y and Y prime. Maybe Y prime is perceived as more pleasant, more desirable, then it might go there. So at this moment...
But at the beginning of the superposition, how would there be any feeling in either one? You have to... Yeah. How do you know which is the better, which one feels better?
Why don't you have sort of like... to be honest, in this idea or in this proposal, what is still missing is sort of what is the natural time scale? Is it the moment of experiment? How long is the moment of experience? How long is a Bing? And does it happen right sort of when the state splits and it's just sort of I have an epsilon population on the one and the rest of the probability is still in the other? Or does there have to be a certain amount? So essentially a suitable time scale is still missing in these ideas, and I don't know how to naturally select
Where's the
that.
time scale in the superposition? I mean, in Roger's view, you have a period between the bifurcation of superposition and then reaching threshold. Time t equals h bar over e sub g. That's the time, and by the end of that, you have clear choices, and one is selected. But I don't see how you have those choices at the beginning of the bifurcation.
Obviously, bifurcation implies a choice if we say you can only ever experience classical states. A choice happens at that moment.
I will have to talk about this over a beer or something. But one more thing. From the beginning, when you have 3 qubits, they're entangled or they're not entangled?
The way how I had set up the circuit, but this is completely arbitrary. We could have picked something else. But here in this example, we apply what's called a Hadamard gate on the first qubit, and it takes the first qubit into superposition. The 2 other ones come along for the ride. But then I thought it's nicer to put some entanglement. I didn't discuss that part into the mix, and then we get to this state.
If they're entangled and they collapse simultaneously, why does that violate special relativity if you have the proper frame of reference?
No, if you measure only the first qubit, and we would then ask again which of the qubits feels anything. If the answer is all 3, then you can use just this R moment or the Bing moments that the third qubit would have, and that was not measured. I could use this to build up a Morse code, and because this qubit now could be way far away, and I could use it to surpass the speed of light to transmit information.
I asked you this before, and you had a good answer, but why aren't they all entangled with the same entity and they're all going to collapse simultaneously?
This is just how the state is made. These are 3 distinct qubits. So in our labs, these are under a microscope. You could see 3 different physical implementations. And it just happens in this circuit that we put them into this superposition state. But once this collapses, these 3 qubits are still there, ready to run the next algorithm. So they're still there.
They're bits after they collapse.
They're bits, but then I can apply the next Hadamard gate and do another superposition.
Will you ever be able to get the 2 observers to interfere with each other and give you in effect the results of a double slit experiment on the?
Yes,
you had 2 observers for a moment seeing red and seeing green, but then somehow.
Yeah, no. If quantum mechanics is as we understand it today, where the time evolution is strictly unitary and there are no nonlinear terms, then the different branches can only interfere. They cannot causally interact. So unfortunately, we cannot peek into the other classical world and check in how is the other David doing over there.
We can't get someone to report an interference effect. I thought part of your idea was eventually we're going to do this with observers who are going to report really weird states of consciousness.
I think they would report if you would. As soon as you make them report and the reports are distinct, then you have decohered them for good.
So they'll just report, I saw red or I saw green. So it's just kind
exactly.
of boring.
Yeah, it's no
one's ever going to report.
No, nobody will ever report I saw red, green, or so no.
So what is the new amazing result you're expecting in the lab eventually? Once you said you're going to do this with people, and eventually not just with organoids, but with people, and then you've got to get some special evidence from what.
Yes, the evidence would be that your the superposition states, let's say, that naturally form in your brain. And I liked Scott's question from earlier this morning, where he asked, do you need entanglement between remote parts of the brain? I think, I said earlier, that conscious experience can be described with rather few bits. So I think maybe this happening in single neurons may be good enough, possibly redundantly, but I'm not certain. Biology is enormously complex, and I wouldn't rule out a priori that there couldn't be longer range entanglement, even though I have never held my breath for that being the case. But back to your question, is the superpositions would, let's say, typically involve, let's say, 100 bits, and now hopefully one day we have 1,000 qubit chip right next to it. Now we can make superpositions involving 1,100, or in the future 1,000,000 plus 100 bits. And that if your participant in this larger superposition as it forms, or if Roger is right. By the way, I should say, we don't have to decide at this point whether you like Roger's idea, conscious moment is when the superposition collapses, versus my flavor of it, I say it happens when the superposition forms. We can leave this to experiment and check then which of the two is right. But in either case, because we now make superpositions that have much larger support in Hilbert space, you would have a more intense experience, needing
they are
more
going to
bits to
report some
describe.
kind of special experience that you don't get in the top.
If AI does it, we never know whether it's sure. If you do it with you have no doubt.
Okay, but Hartmut, on that note, like I wanted to say before, like you said to Susan, well, if only we could do, entangle my entire brain with a qubit, right? Then you could just ask me, like, did that feel amazing, right? But I think yet again, you would learn nothing new beyond the validity of quantum mechanics, because as soon as you ask me what it felt like, then you've measured me.
No, but you could report back.
Well, no. But my report afterward is also a measurement. Only my experience while the experiment is in session. Depending afterwards, I have no memory of it.
Okay, then I go myself in the machine and say, "Hey, life is awesome. I don't care whether."
All right,
I'm convinced.
Well, I think this is a perfect place to end a really cool day. I want to thank all of our speakers. Hartmut, that was awesome. And David, Scott, Mark, the whole crew.
Firstly, thank you for watching. Thank you for listening. There's now a website, kurtjaimungal.org, and that has a mailing list. The reason being that large platforms like YouTube, like Patreon, they can disable you for whatever reason, whenever they like. That's just part of the terms of service. Now, a direct mailing list ensures that I have an untrammeled communication with you. Plus, soon I'll be releasing a one-page PDF of my top 10 toes. It's not as Quentin Tarantino as it sounds like. Secondly, if you haven't subscribed or clicked that like button, now is the time to do so. Why? Because each subscribe, each like helps YouTube push this content to more people like yourself. Plus, it helps out Kurt directly, aka me. I also found out last year that external links count plenty toward the algorithm, which means that whenever you share on Twitter, say on Facebook or even on Reddit, etc., it shows YouTube, hey, people are talking about this content outside of YouTube, which in turn greatly aids the distribution on YouTube. Thirdly, there's a remarkably active Discord and subreddit for Theories of Everything, where people explicate toes, they disagree respectfully about theories, and build as a community our own toe. Links to both are in the description. Fourthly, you should know this podcast is on iTunes, it's on Spotify, it's on all of the audio platforms. All you have to do is type in Theories of Everything and you'll find it. Personally, I gain from rewatching lectures and podcasts. I also read in the comments that, hey, toe listeners also gain from replaying. So how about instead you re-listen on those platforms like iTunes, Spotify, Google Podcasts, whichever podcast catcher you use. And finally, if you'd like to support more conversations like this, more content like this, then do consider visiting patreon.com/KurtJaimungal and donating with whatever you like. There's also PayPal, there's also crypto, there's also just joining on YouTube. Again, keep in mind, it's support from the sponsors and you that allow me to work on Toe full time. You also get early access to ad-free episodes, whether it's audio or video. It's audio in the case of Patreon, video in the case of YouTube. For instance, this episode that you're listening to right now was released a few days earlier. Every dollar helps far more than you think. Either way, your viewership is generosity enough. Thank you so much.